30, 60, 90 triangles also like to hide in hexagons. Okay. A hexagon is a six-sided polygon. All of the angles are 120 degrees. Okay. If I draw the center, and again, my hexagon is probably not drawn to scale because I did freehand the hexagon. If I draw the center and I draw what's called a circumradii, circumradius for one, circumradii for two. Okay, that circumradii is going to bisect each of those 120 degree angle and make 60-degree angles. Okay, well, if two angles of a triangle are 60, the third one has to be 60 because the measure of the angles has to add to 180 degrees. Okay, so within a hexagon is an equilateral triangle. So equilateral triangles are hidden in hexagons. And then we just go back to our regular routine. If we bisect our equilateral triangle, that bisector creates a 90-degree angle. We have a 60, and then we now this one at the top is now 30 degrees. So equilateral triangles hide within hexagons, and then we already know 30, 60, 90 triangles hide in equilateral triangles. So let's look at two examples of how this works on an exam. A hexagon is shown with the given information. Find the value of x. So let's look at what information is given. Okay, so we see the 60 degree and the 60 degree. We see a bisector that created a 90 degree. And then we're given the length of that circumradii. Circumradii means it goes from the center to a vertice, not center to the side. Okay, well, if this is 60 and 60, we know this was an equilateral triangle that was bisected. So we know that this angle here is 30 degrees, which means the information I'm given is the side across from 90. You know, the side across from 90 is 2x. So 2x is equal to 10 radical 2 divided by 2. So x is equal to 5 radical 2. Oh, I know my side across from 60, or my bisector, is always x times radical 3. And don't confuse, let me make this x sub 1, because we don't want to confuse it with the x we're looking for. So we know the x we're looking for is equal to x sub 1 times radical 3 because it's my side across from 60. So it's equal to 5 radical 2 times radical 3, which is 5 radical 6 units. A hexagon has a perimeter of 48 units. Find the length of x. Okay, let's dissect what information we're given. A hexagon has a perimeter of 48 units. We know a hexagon has 6 equal sides, so 6s is equal to 48. So s is equal to 8 units. Okay, so that's telling me each side of my hexagon is 8 units. Okay, now I know that this bisector splits this length in half. So I know this side here, because there's a bisector there, is 8 over 4, sorry, 8 over 2, which is 4 units. Mistakes are okay as long as you correct them. So I know my side across from 30 is 4 units. That means that my bisector, or the x that I'm looking for, is 4 times radical 3 units.